Hello everyone and welcome to today's lesson. I'm Mrs Jennison and I'm an Associate Director of Science at Outgrange Academies Trust, and today we will be looking at the Earth and the atmosphere. So before we start, it would be really useful if you could turn the notifications off on your devices. This way you can take part in the lesson and really focus your attention. It would also be really useful if you had a piece of paper and a pen to hand so that you could take part in the activities throughout the video. This lesson is part of our Saving Planet Earth topic, and we are starting this topic today by looking at the structure of our Earth and the atmosphere. Our challenge is to be able to describe the structure of the Earth and name gases in the air. Our aspire is to be able to compare the properties of the layers of the Earth. And we're going to start today's lesson with a little song.
Layers of the Earth. Layers of the Earth. Throw your hands up for layers of the Earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Throw your hands up for the layers of the Earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. The layer we'll discuss first is the central inner core in the center of the Earth. A solid ball buried below the dirt.
We believe it's primarily metallic iron.
You could never take a trip to the inner core, right? The heat will burn you up 9,000 Fahrenheit, 4,000 miles below the Earth's crust. One down, three to go, y'all. 1,800 miles from the tip top. The outer core is hard at work and it don't stop. It's busy spinning around the inner core.
And listen,
This steady movement causes Earth's magnetism. Ranging from 4 to 9,000 degrees, it contributes 1/5 of the heat flowing to you and me. It's liquid metal that violently flow. So let it settle when you're ready, let me know. Just throw your hands up for the layers of the Earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Throw your hands up for the layers of the Earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. The mantle layer is the largest of the class, about half of our planet's mass. The mantle is composed of very hot, dense rocks that move and flow, always on the go. They never lock, never stop, and responsible for tectonic shift.
please believe.
Earth's plates are adrift. It's pretty thick, y'all, and the heat is awesome. 1,600 at the top, 4,000 at the bottom. The continental crust surface is where we breathe. A lot of rock up to 25 miles deep. The oceanic crust is just next door. It's 3 to 5 miles thick below the ocean floor.
Earth's surface?
70% H2O.
Where you get all that water?
Salty sea flow. The rest is fresh water in the glaciers, ice caps, and snow. Let me see you throw your hands up for layers of the Earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Throw your hands up for the layers of the Earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust.
The Earth is almost a sphere. These are its main layers, starting with the outermost, so working from the outside in. The first layer is the crust, which is relatively thin and rocky. That's the part of the Earth in which we live. Then we have the mantle. The mantle has the properties of a solid, but it flows very slowly. It's made out of molten rock and it's incredibly hot. We also have the core. Now that can be separated into the outer core, which is a liquid, and then the inner core, which is a solid. These are made from nickel and iron, so they are metallic. The radius of the core is just over half the radius of the Earth, and surrounding the crust is the Earth's atmosphere. The Earth's crust, its atmosphere and the oceans are the only sources of the resources that humans need. So everything that we utilise on Earth to make our devices, to make our food, is found within this area, on the crust and in the atmosphere and oceans. Now, from the crust, we can obtain many different resources, from metal ores to crude oil, which can be used as fuels and also to make plastics. We can also extract rocks, which can be used as useful building materials. Now, if we were to summarise the layers of the Earth and the atmosphere, if we started from the outside in, technically we would start with the atmosphere, which is our air, which we refer to commonly as air, and that is a gas. Then we have the crust, which is solid and it's rocky. Underneath that we have the mantle, which has some properties of a solid but also can flow like a liquid, so it can be described as semi-solid. Then we would have the outer core, which is a liquid, and then the inner core, which is a solid. So now it's time for you guys to complete a small task. I'd like you to name the layers of the Earth, give some features of each of these layers, and say which layer of the Earth we live on. So the layers of the Earth, we have the inner core, outer core, mantle and crust, and also the atmosphere. Some features of these layers are seen on the screen. I've put the properties and the states of those layers. So we've got the inner core solid, outer core liquid, mantle semi-solid, crust solid, and atmosphere gas. The layer that we live on is the crust. So over this topic, we are going to be looking at how we obtain resources from the Earth and how our use of these affects the Earth. But before we do that, we do need to look at the atmosphere, because some of our use of resources can dramatically affect our atmosphere. So really quickly, just to see if you already know any of these, can you list any gases that are found in the air? So the air consists of around 78% nitrogen. You may see this written in some textbooks as about 80% nitrogen, 21% oxygen, and then around 1% of a gas called argon. It is made out of many different gases, but those three gases are the most abundant, which are the ones that have the highest percentages. Now, those three gases comprise of 99.9% of the atmosphere, and the remaining 0.01% of the atmosphere is consists of gases such as carbon dioxide, which is around 0.04%, and water vapour, which can vary dependent on the humidity. Now we can actually measure the percentage of oxygen in air with a very simple experiment, which involves 2 gas syringes, some copper turnings and a Bunsen burner. And I've found a video of this investigation to show you.
Experiment 123B. Oxygen content determination using syringes and copper. We start with the overview of all products needed to do the experiment. The first syringe is filled with 100 milliliters of air. The other is at 0. First we light the Bunsen burner and start to heat the tube with the copper inside. We now start to move the syringes to and fro for approximately 50 times to pass the air in the syringes over the hot copper. We continue the heating and the moving. As we go along, we see the color of the copper changing from red into black-blue. All the air has to move over the copper to let the oxygen in the air react with the copper and become copper oxide. At the end, we see a stabilization of the amount of air left in the syringes . The only gas in air that will react with copper is oxygen, so we can conclude that 21% of the air is oxygen.
Seen all of that, it's time for a quick multiple choice quiz. So first, I'd like you to give the percentage of nitrogen in the atmosphere. Your choices are A, 78%, B, 21%, C, 0.9%, or D, 0.04%. And the answer is A, 78%. Now I'd like you to give the percentage of carbon dioxide in the atmosphere. Your choices again are A, 78%, B, 21%, C, 0.9%, and D, 0.04%. And the answer is D, 0.04%. Give the percentage of oxygen in the atmosphere. Your options are A, 78%, B, 21%, C, 0.9%, and D, 0.04%. And the answer is B, 21%. Give the percentage of argon in the atmosphere. A, 78%, B, 21%, C, 0.9%, or D, 0.04%. And the answer is C, 0.9%. And then I'd like you to give the layers of the Earth from the inside to the outside. So we're working from in to out. So your option is A, inner core, outer core, mantle and crust. B, outer core, inner core, crust and mantle. C, crust, mantle, outer core and inner core. Or D, mantle, crust, inner core and outer core. And the answer is A, inner core, outer core, mantle and crust. So let's have a go at a practice question on this. The diagram shows a section through the Earth and its atmosphere. So it's like a cross section, like they've taken a piece out of the Earth, like a cake. We have the atmosphere labelled, and then we have two sections, A and B. They'd like you to use the words from the box to label parts A and B on the diagram. And I'm going to give you a minute to do so. The bar chart shows the percentage by mass of gases in dry air. Two of the gases have been labelled as A and B. What are the names of gas A and gas B? So now it's time to check your answers. When you were asked to name parts A and B of this diagram, A was the mantle and B was the core. Using the graph to name gas A and gas B, because gas A is about 78% when you read it off the graph, gas A is nitrogen. Gas B is around 21% if you read off the graph, which means that gas B is oxygen. Now that's everything from me this lesson, and I will see you soon.